Hi. In this e-learning I'm going to show you how to remotely turn your PC on or off with an ESP. So what I mean by that is we have a different network. That could be a phone with data or just another PC in another VLAN. And that's going to connect to the internet, and from there it's going to go on a web server hosted by the ESP. And the ESP will react to whatever the client does on the web server and will correspondingly turn the other PC on or off. A little disclaimer, I'm no professional. In fact, I did this for the first time, like anything like this. I'm just going to explain step by step how I did it in my way. So the steps are as following. The first step is going to be soldering the relay. What the relay is, we're going to talk about a second. We're going to talk about programming the ESP, then about creating the web server, then about port forwarding, and then the last step we're going to install the ESP and the relay. Okay, the components you need for this obviously is the relay and the ESP. So the relay is nothing else than a switch, which is basically going to turn on or off the power supply, similarly to like the button does on your PC. And the ESP is something like an Arduino, but with a Wi-Fi module on it. You can actually see it on the little golden plate on there. It says Wi-Fi. And yeah, the ones that I took are called the GRV Relay 1 and the Node MCU. I got them both from Reichelt, which is a German company. I'm not sure how accessible the components are there in other countries. If you're not from Germany, you might try a different option, but I took Reichelt. So obviously you need a working PC to perform this on, so you can switch something on or off. Theoretically, it could be something different than a PC. It could be a lamp or a microwave, but yeah, I did it with a PC. You need some spare cables and a bit of isolation, so yeah, it's always to have a bit of backup, always good. Then you need a second PC or a laptop to operate the ESP while the other working PC is out of order, because we're gonna obviously unplug it and decommission the button to turn it on or off for a while, so you need a different PC to still program it, like if you made a mistake or something. Then we need a soldering station to connect some wires together. Well, soldering the relay, that's the next step. So, this is the cable connecting the relay to the ESP. This is ground, which is the negative. This is VCC, which is the positive. This is no connection. In our case, this is not important in any way. And this is the signal. The positive and the negative are needed to power the switch itself, so that you can turn off the power flow in the PC, and the signal is needed to tell the relay to either close or open the switch. Yeah. So this is the ESP and this is the relay, and it would be good for us to have all those three connections close together, and in my case they're right there, all three together. So we're gonna connect them something like this together. How does one solder? That's a very good question. As you can see on this note that I wrote, I asked myself the very same question. Well, if we translate this gibberish into something readable, we realize that there's some stuff that we need. All the information I got from this YouTube video. It's called Soldering 101. For Arduino projects. It's very helpful, probably the best you will find. It's about 30 minutes long, and it'll explain everything you need to start soldering as a beginner. If you don't have a teacher nearby or somebody else who can teach you how to use the stuff, this is probably the best option you have. Well, it's what I used. And, well, we need a soldering iron, that's for sure. We need also some solder to connect the components together. We need a desoldering pump. This pump is needed to clean up afterwards, like the iron tip, or to clean up if we made a mess on the circuit board. We also need a third hand. This is very useful if you want to connect stuff. And for our own personal safety, we need eye protection and some ventilation. ventilation, that could be just a very big room, that's also good, but we could also have some open windows that should at least take care of some of it. And obviously, if you're in a small confined room, there needs to be ventilation in there, otherwise it could be dangerous. Make sure that the solder is lead free. Most of them are green, but read them to make sure. If they are not lead free, they are toxic, so don't inhale them. Don't inhale them in general. And also do not touch the hot solder. It's very hot. Also do not touch the tip of the soldering iron. Well, in my case, I didn't have a third hand. It's fine. It's optional. I used some pliers to fix it. I also didn't have eye protection. I couldn't find some goggles, so I used those sunglasses over there. The room I was in was very small, didn't have windows, and wasn't ventilated. They just didn't put it in there, so I didn't have ventilation. I opened the door and hoped that it helped. Also, the solder was obviously not lead free. Yeah, that's a bit of a bummer. And I managed to inhale just some of it. And also, in the end, I didn't have a pump. So, if you are in my situation, do not solder. It's dangerous, very dangerous, in fact. But I did it anyways. If you take a look at the note that I wrote again, you can see that I wrote some neat instructions down there, how to connect the relay to the ESP. So what I didn't write there is that we need to behead, obviously, the other side of the cable so that we can solder them together. And they should look something like this. Make sure that the exposed wire is not longer than 1 to 2 millimeters, because if they get longer, they could overlap and that wouldn't be good. Then we want to solder in those, that would look something like this. And then we want to connect them to the ESP board without any more solder. Yeah, as you can see with the red cable, it didn't quite work out, so I added a bit more solder and it made this weird bubble. Doesn't matter, they don't touch each other, so it's fine. And afterwards, obviously clean up with a pump, for example. Yeah. If you're done, it should look something like this. Yeah. What does one need for programming the ESP? We need a laptop. The one we talked about earlier would be nice. We need some cables to connect the ESP to the laptop. And we need the Arduino IDE. So, if we look at my first note, we can make out some vague instructions on how to install the Arduino IDE. So first of all, you need to Google Arduino IDE and download the newest version. When you've done that and installed it, you should go to Files, Preferences, Additional Board Manager URLs, and paste in those two links right here. If this video has a description, I will put them there too. Otherwise, they're displayed right here. And if you paste them in, they should look something like this. What they do, they add some libraries and some other useful stuff to make the ESP work actually on the software. Next step is to select your board. So you go on Tools, then you go on Board, then you go in this ESP8266, and then you select the Node MCU 1.0 ESP12E module. This obviously is only the right board if you're using the same ESP as me. If you're using a different one, you need to look up how is yours called. Mine was written on the package how it was called, and you need to select it then there. So then make sure that the driver is installed for your ESP. They are on different places on the internet. It's a bit hard to find them, but you will manage. Afterwards, find the right port for your ESP. In many cases, you've been told. In my case, I just found it out through trial and error. It's port 4. And afterwards, you need to inform yourself and use the manual. And if you use that, you will figure out something simple like this, which is just a 1 second interval in which the relay will be activated and deactivated. The relay is pretty loud, so you will hear a clicking noise if it works. Also, the ESP should have a blinking light correspondingly. So you might be asking, what is the manual? Well, it's a very useful site, obviously contributing to the Arduino IDE. which just displays all the functions and variables you have. So it's written in C++, the IDE, not the website. It's pretty manageable. You can find everything you need right here. And for each and every one, you have a detailed explanation of each function and variable. There are examples for everyone that I looked at. I didn't look at everything, obviously, but as far as I could tell, there are examples, and there is also no filler text, which means that they get straight to the point, still in a detailed way, obviously. Like I said, very comprehensive, very good, not too long. If you're just starting out, this is probably a good place to find everything you need instead of Googling around. Well, on to step 3, creating a web server. Well, this is a beginner's guide to the ESP8266. It's very big. There's literally everything you need to know about the ESP8266, like from its components, how it was made. There's everything in there. There are examples for you to try it out, like different coding lines to start your own web projects. It also explains to you how to use the console on your computer to ping the ESP and see if the connection works. I highly recommend chapters 7 to 9 because those are the most important ones to creating a web server. And there's a tiny problem actually. MDNS doesn't work on every PC. It seems to be hardware dependent, and the way he explained it, the maker of this essay, it didn't work on my side. After a good chunk of digging, I found a solution. If it doesn't work on your PC too, in the loop, which is something like an update, you write in this line of code and it should work. If it doesn't, you made another mistake. Yeah. Well, anyways, in there you will find everything you need. Explaining how to actually make a web server would be way too long for this video, but this essay explains it way better than I ever could anyways. Now let's go to port forwarding. You might have heard about this little indie game called Minecraft. And if you ever try to make a private server on there, you encountered port forwarding. So how to activate port forwarding? You go into your console. If you pinged before, if you used the essay, you should know how to open this. And in there you write ipconfig and press enter. Afterwards you will find a number that looks something like this on the bottom. And if you type that into your browser, you will end up at your router where you need to log in. The password for that should be on your router. If somebody changed it, well, that's a problem for you. Well, if you get in there, and now it gets a bit tricky because every router looks a bit different. In Germany, there's a very common router called Fritzbox, and that's the one that I had. Blurred out things, by the way, is not normal. I did that so that you don't see my IPs. Well, if you go to internet and Freigaben, well, it's for the Germans now only, but you can add a new device. You can add a new device. That should be something that you should be able to do on every router. When you add this device, there will be a few things displayed. The only thing that you are interested in is to make a new opening, a new port, basically, or a new forwarding. I don't know how it's called in English. And it should be something like this. So the purpose for it should be a HTTP server, and the protocol should be TCP. And now about the port. The port, you can basically name it whatever you want. If you want to be sure, I recommend numbers between 500 and 2500, but it actually doesn't matter. There's a max limit. I'm not sure what it is, but it's around, I think, 5000. If you go lower on the numbers, there will be lots of ports that other devices might use, which is not recommended. The standard ports for web servers like these are 80, but because port forwarding is pretty unsafe, I would at least change the port to something else. In this example I chose 999. It's not what my actual port for this project was. Yeah. Now we need to find out what your IP address is. Well, you need to find it out, I don't. You go to my website, which is called What is my IP address, and it's gonna display your IPv6 and your IPv4. I have an IPv4. If you don't have an IPv4, you might have a problem. I don't know. You need to find a way around it. The way IPv6 works is they kind of transform into IPv4s if you use them as a client. It's not a problem if you are a client, it doesn't matter. But as soon as you are hosting stuff, you might run into some problems. So you should look them up. If you have an IPv4, everything is fine. So you're gonna select that IPv4, copy it, and now it's pretty easy. You're just gonna use your IPv4. I just changed all the numbers to 0 because I don't want to show my own IP. And you're gonna write the port behind it like this. So, like I said, if you followed the essay before, you should be able to open your web server locally. Now with this IP and this port, which corresponds to your ESP, you should be able to come to the same web server with just this. Just type this into your browser. Well, that was port forwarding. Now to the last step, install the ESP and the relay. I had some good screwdrivers and everything around because I work a lot with PCs, so that wasn't a big of a problem. What we want when we disassemble the PC is we want to reach the motherboard. As you can see in my case, I needed to remove the connection that's held up the storage. We need to remove a button, and mine looked like this. And you need to make sure that you remember where the button was connected exactly. I mean, it counts for everything. You need to remember exactly where everything was connected. But the button is especially important because it's connected directly to the motherboard. And now for the most tricky part, which probably is going to take you a good chunk. You need to figure out how your motherboard is called and then look up the manual on the internet. I found it because we need to find the panel that the button was connected to. Because in my case, and in probably your case too, the button alone is not going to tell you what cable is, like what is what. If we find it, and we found the F panel, which probably should also be the F panel for you, you never know, motherboards are different. Yeah, in my case I could figure out that this dark blue cable is negative and the white one is positive. On the other side, there's also a circuit controlling some LEDs, but it's not important for me. Those two cables are the ones that are interesting. So, basically, this sounded all very easy, and it actually is very easy, but it still took me a long while to figure everything out. But what I eventually came up with, if I decipher this note again, is this. Yeah, it's pretty simple. This is the button on your PC. It's a closed cycle, and when the button is pressed, well, then it's actually closed, and the motherboard gets in some power, and depending on the state which your PC is in, it's gonna get switched off or switched on. And if the button is released, no power is flowing, so no interaction with the motherboard. So if we put our relay right there, it serves the exact same function. It's not recommended to press both buttons at the same time, like the relay and the button. It shouldn't be dangerous, but you never know. You might try it. I don't recommend it. Well, make sure to connect the relay to the ESP, and also make sure that the ESP is outside of the PC casing, because the PC casing is pretty dense, and you might have no connection to the Wi-Fi if the ESP is inside. Then plug in a USB and connect it to the ESP, so the ESP has power. And also make sure that ERP is disabled in your BIOS. This way the USB still delivers power to the ESP even if your PC is off. Yeah. Now to the last step, we need to achieve this. Cut the ground and VCC open of the button and solder in 2 new cables. It should look something like this. Because I soldered at home, I used my baking plate. That's why it looks so weird. Ignore that. The important part is that there are now 2 cables in there. Screw the 2 new cables into the relay, like this, and make sure to isolate the open cables right there. I don't have a picture of that, but that shouldn't be open like that. After this, all you need to do is obviously test it, but then you need to screw the PC together, put it in place, and after that, if you did everything right, you are done. So, fahr mal runter und zeig, dass du mobilen Daten drin bist. Ja, WLAN ist aus, okay. Da ist der PC. Halt mal so rein, dass man es auch sieht. Genau. Ja, und jetzt drück Login. Oh. Oh. Yes! Okay, 1 zurück. Sehr gut. Der ist noch am Runterfahren. So, okay, und jetzt drück's nochmal. Yes! Thanks for looking at my e-learning.